Now that we've talked about counting significant figures and you've already learned about the math rules for significant figures, we can start to apply those to actual math problems. So on problem number 1, you look at the math that's going on here. This happens to be only multiplication. And so we need to count the number of significant figures in each of our numbers. So this first one has 2 sig figs, the next one has 3, and then the last one has 3, which means that we can have 3 significant figures in our final answer. If you plug this in your calculator, the number that you get is 413.22. So there's a few digits right there. Now, of these 3 numbers, the multiplication division rule says this: you can only report your answer to the least number of place values from your numbers going into your calculation. So since 2 is our smallest answer, or smallest number, we can only have 2 place values in our final answer. So we have the 4, which is in the place value called the 100s, and then we have the 1 that's in the place value called the tens. So we're only able to use those 2 place values, which means that we have to only round to this number right here, the tens position. We have a 1 trailed by a 3, which means that our final answer has to have a 4, and then whatever rounding happens with a 1 trailed by a 3, which is just a 1. But then since this is in the tens place value, we have to put something behind it so that it pushes the 1 into the tens and we can put a 0. So now if we look at this number, if you would have had this up at the top, we only have 2 significant figures because these 2 follow rule number 1, non-zeros. This 0 is not a sandwich 0. And then even though it's on the right-hand side of a non-zero, we don't see a dot, so it doesn't count. So these are 2 sig figs, just like we predicted we would have right here, because 5.6 has only 2 significant figures, and this is a multiplication division problem. Now if we go down to the next math problem, this is addition subtraction, and instead of counting the number of place values, we look at the place values and say which of these was measured on the least accurate device. So if this is a balance, this balance might cost me to buy from a science store like $900 to buy a balance that can go out to the thousandths place value right here. This balance that can go to the hundredths, that might be a $400 balance for me to buy. This one that goes to the tenths right here, I just bought actually several of these off of Amazon, and I could buy them for like $15 each. So if I'm going to rely on the math using these 3 different numbers from 3 different balances, I can only have my final answer be as accurate as my weakest measurement, and that's this one right here. Since my estimated place value is in the tenths place value, my answer can only go to the tenths. So if I plug this into my calculator, I end up getting a number that's 10.633. And so again, I can only go to my least accurate place value. My least accurate place value is called the tenths. Additionally, if you think about this, I knew this number, but then I start getting into estimations because this was an estimate in the 0.7 number, and this 4 was an estimate in the 2.34. And then finally, since this last 3 is an estimate from the 8.993, if I were to keep all of this, I would have a number that says, I know a place value, I know a place value, I'm estimating a place value, I'm estimating. That's not allowed. We're only allowed to have one estimated place value. So now this 6 is trailed by a 3. I have to say what happens to the 6, what stays the same. So my final answer is 10.6, and that's the one that I can write down and actually keep for problem number 2. So what happens when you happen to have 2 math processes happening at the same time, like problem number 6? In that case, we have both subtraction and we have division, so we need to see what's going on overall. Now, if we happen to look at this problem right here, we have the numerator that we have to actually do some subtraction for. So if we do the subtraction for that, we get 22.31 minus the 25.7, and that's going to equal negative 3.39. Now, if I stopped right there, I would literally round this to whatever is my better number here or my worst number here. Since this is subtraction, this one goes out to the hundredths, this one goes out to the tenths. Tenths is less accurate than hundredths. This is the cheaper balance per se. So my answer can only go here. So then if I stopped right now, I would only be able to have the ones place value and the tenths place value. But I'm not going to round in the middle of my problem. So now I'm going to divide by my 4.6. And if I divide by my 4.6, I end up getting negative 0.7369. That's an awful 9. So going back to what we had, this was a 3 and a 3 and a 9, where only this one, the 3, and the second 3 place value count. So here's a 2 significant digit number divided by a 2 significant digit number. Even though this has 3 digits, we only know that this is the one that counts, the 9 doesn't count. So we have a 2 divided by 2, which means I can have 2 in my answer, and then that means that I can go only to this place value here. 3 trailed by a 6 turns to 0.74, and that's a negative number as my final for question number 6.